So this video should help you prepare for problems on the final exam that deal with chapters 6 and 7. Alright, so let's look at this problem right here. Let's think about what it's asking. It says give the domain of the rational function using set builder notation and interval notation. Now remember, with rational functions, what we're looking for are values that make the denominator equal to 0. And those values that make the denominator equal to 0 are excluded values. Remember, they're excluded values. So what we do is set that expression in the denominator equal to 0. So it tells us that y equals 7 will yield 0. So basically what we're saying is y cannot equal 7. So the reason being is, if we were to let this function equal to 7, we would get 7 over 7 minus 7, which yields 7 over 0. Notice that we have division by 0. That makes this undefined. So for that reason, 7 is an excluded value. So notice part A wants it in set builder notation. Remember, set builder notation identifies excluded values. So if we look here, it says y is a real, set of all y's, where y is a real number, y not equal to some value. And we just figured out that that value was 7. Then the second part of this question asks for this domain in interval notation. Remember, interval notation shows you what values are included in the domain. And remember, set builder notation involves the parentheses and the negative infinities and the unions and things like that. So we're looking for all values except for 7. So we represent that in interval notation as negative infinity to 7, not including 7, so we use a parentheses, union 7 to infinity. So what this is telling us is that we have all real numbers except for 7. Again, emphasizing, set builder notation indicates what values are excluded, and interval notation indicates what values are included in a domain. So let's look at what this problem is asking us. It's saying to write the rational expression in lowest terms. So what we're looking for are any terms that are common in both the numerator and the denominator. Notice right off the bat, if we were to zoom in here, that y minus 4 is common in the numerator and the denominator. So we can say that those two things cancel out. So this can be rewritten in simplified terms in this way. So here we have another problem that's asking us to write the rational expression in lowest terms. So remember, the procedure is to factor both the numerator and the denominator and determine if there's anything that will cancel out. So let's go ahead and rewrite the expression. You have 5t minus 5 over t squared minus 1. So notice we can factor out a 5 in the numerator, and that gives us 5t minus 1. Now notice something about the denominator. That denominator is the difference of two squares. Remember, the difference of two squares factoring formula was right here. Alright. So we can rewrite that denominator as t minus 1, t plus 1. Notice that t minus 1 cancels out. So we're left with 5 over t plus 1. And that is now in lowest terms. Okay, so this one says perform the indicated operation. Alright, so once again we have two rational expressions that we're going to combine through subtraction in this case. So the first thing we got to do is find the lowest common denominator, and that would be the multiplication, the product of both of these denominators, which is here x times x minus 18. And what we're going to do here, so we would take x times 1, then we would take negative 1 times x minus 18. What we'll do is we'll just do this right here, negative x minus 18. And we'll continue on with this. We'll distribute that negative, so it'd be x minus x plus 18 over x times x minus 18. These x's here are going to cancel out. So what we're left with here is 18 over x times x minus 18. And that's lowest in its lowest terms. Okay, so first off, notice it's asking us to simplify. Alright, so there's a couple ways to look at this. One way to look at this was to rewrite this in such a way where we have rewritten in such a way that has a fractional exponent. If you remember, when we rewrite these using fractional exponents, the denominator is the index. So what we would do, we would apply the power rule here, so we would get x to the 25th over 5, which is actually x to the 5th. So we just simplified that. Now another way to think about this that I told you about was to, whenever you have a variable raised to some exponent, is to divide the exponent by the index. This may not be the correct mathematical way to describe this, but it's the same thing that's happening in the previous way that I described it. So basically, here's what we have. We have the 5th root of x to the 25, and we're actually dividing that exponent by the index, and we get x to the 5th. So those are two ways to simplify this expression here. So this question is asking us to multiply using the product rule. Now, the product rule implies that when given two radicals, we can multiply what is underneath the radicals. So we have the square root of 162 times the square root of 2. So if we were to multiply what is underneath the radicals, we would get 324. Now if we were to take the square root of 324, we would get 18. So this simplifies down to 18. And that's all there is to that problem. So here we have another example where it says multiply using the product rule. And again, remember, we simply, when dealing with two radicals, we can simplify those two radicals by simply multiplying by what is underneath the radicals. So we have a square root of 11 times the square root of q. So this simplifies into the square root of 11q. And again, that's all that is to those types of problems. So here, this problem here, we're asked to simplify this radical expression. So let's just move this up here so we can have room to work the problem. So what we have is negative 9 square roots of 3 plus 8 square roots of 27. So looking at this one is already simplified. However, we've got a little bit of work to do with this particular radical expression to combine these two. So remember, when we're simplifying radical expressions, what we're looking for are any factors that are perfect squares. So we could use a little factor tree here, but basically 3 times 9 yields 27. So we're going to rewrite this in this way. 9 times 3. So we're going to take the square root of 9 here. So this is going to be rewritten as 9 square roots of 3 plus 8 times 3 square roots of 3. This will simplify down to 9 square roots of 3 plus 24 square roots of 3. Now remember, we talked about how this can be thought of in the same way as simplifying something of this nature. So negative 9x plus 24x would yield 15x. So in the same way, negative 9 square roots of 3 plus 24 square roots of 3 is going to result in 15 square roots of 3. And that's our answer. So this question is simply asking us to rationalize the denominator. Remember, based upon the rules of simplifying radicals, we can't have a radical in the denominator. So what we do to rationalize the denominator is multiply by a form of 1, which is multiplying by the numerator and the denominator by whatever radical is in the denominator. In this case, it happens to be square roots of 6. So now we apply the product rule, which remember means that we multiply by whatever's underneath the radical. So 5 times 6 yields square root of 30. And the square root of 6 times the square root of 6 is the same thing as the square root of 36, which simplifies down to square root of 30 over 6.